is possible that a wrong train will enter into the block section instead of the right train. So this happens with the paper authority. So let us generally the paper authority is avoided, but if it is not possible to give the line clear or give the authority to proceed by any other means, then the paper authority is the only mode left with the station master to authorize the train to go into the block section. Now I have a question, so let me search for the question if it is available here. Now here is the question for you. Okay, I am closing the poll. Most of you have replied correctly that authority to proceed cannot be handed over if the line clear is not obtained. But some of you, 10 of you have said that yes, it can be handed over. When if it is to be handed over, in case the line clear is not obtained, then the entire system of working fails. The block section is occupied, and still you are giving authority to proceed means you are permitting a train when the train is already in the block section. So you cannot give authority to proceed unless until you get the line clear. So that is not correct. And 14 of you have not answered. The reason is unknown. I don't know why it has not been answered. So let us move ahead. Then we'll move on to the next topic, which is also known as adequate distance and more properly known as overlap. Now, when a train moves from, say, station A to station B, then and if it is required to stop at the first stop signal, or in other sense, if it is required to stop at the home signal, it is possible sometimes that due to various reasons the train may not be able to stop at the short of home signal, and the train will travel for some few meters more than that. Though a driver is not supposed to to cross the stop signal at red or at danger, at any cost, and the penalty which is specified for if the driver crosses the signal at red is removal from service. But in case there is some problem with the train, either with the brake power or with the loco or some other issues are there, then there are chances that the driver, despite their best effort, will not be able to stop the train short of home signal. So in order to avoid any accident immediately after the driver crosses the home signal or driver crosses the signal for few meters, even if the signal is not given, then certain distance is always kept free. Certain distance is kept free of hindrances. Certain distance is kept free for obstruction beyond the home signal towards the station, and which is also known as adequate distance and which is known as overlap. So this overlap is generally kept beyond the signal so as to take care of the in case the driver crosses the signal if it is not given for the driver. So this is one of the overlap which is block overlap. A train coming from the block section pays to stop at the another station if it is required to stop. Second is signal overlap. Suppose the train is moving within the station yard, say from home signal to say starter signal, and starter signal is not cleared for the train, then the train traveling from home signal to starter signal should stop short of starter signal. But again, for the some issue, the train crosses the starter signal, then the distance beyond the starter signal is kept as the overlap, as the adequate distance, so that the train does not meet with any obstruction or obstruction immediately after the uh, after crossing the signal. So there are two types of overlap. One is block overlap, and another is signal overlap. As you see in the diagram, train has moved from station A. Cannot wait. Train is moving from station A towards station B. Now, station train crosses the last stop signal, which is for station A, which is also known as advanced starter. So the train crosses the signal, so it is there in the block section. This is the block section. So the train crosses the advanced starter and enters into the block section and is going towards station B. Now this signal is not given for the train. This is the home signal which is at red. So typically the train should logically stop here, short of the home signal. But the train can cross this home signal for various reasons. So this distance which is beyond the home signal, this distance which is beyond the home signal should be kept free, and it is the adequate distance which is also known as overlap. So this is block overlap. And in case the train is moving within the station and is crossing the home signal and is required to stop at the starter signal, the train is not able to stop here. The train crosses for few meters. So this distance is kept free from any obstruction so that the train does not meet with any accident. So this is known as signal overlap. Signal to signal movement is for the signal overlap, and the train coming from the block section, it is the block overlap. The block overlap distance is always more than the signal overlap distance. Block overlap is 180 meter, whereas the signal overlap is only 120 meters. So block overlap is more because the train coming from the block section is traveling with a higher speed and is traveling in a section which is not accompanying any signal. So the train may be going as per the booked speed. And once it reaches the stop signal, the home signal, the distance which it can cross after application of brake is more than in case the train moves from signal to signal. So in that case, the speed is not that much, so the overlap is small. So the signal overlap will always be less than the block overlap. Here another way of showing it, and there is a small difference in the way the signal overlap is shown in the double line as well as in single line. In the double line, the signal overlap is from starter to advanced starter. Starter to advanced starter is the signal overlap in case of double line. In case of single line, it is from the outermost point to the advanced starter. This is the difference in the two overlaps. So, in case of single line, the distance available with the train is much more as compared to the double line. As you can see, the margin available with the train in single line is from starter to advanced starter. Now this is signal overlap, so obviously this is 120 meter. So 120 meter plus the length from starter to this point. So it may be around 180, 190 meter. Whereas in case of double line, it is from the starter to advanced starter, so it is typically 80 meter. 120 meter and not more than that. So single line, there is a difference in the single line and double line.
Excuse me,
So the way, yeah,
sir. The signal overlap is from the point to the advanced starter, from starter to advanced starter.
in case of double line, it is from starter to advanced starter. But in case of single line, it is from the outermost trailing point to the advanced starter.
Thank you.
Now the outermost trailing point will be at a distance from the starter signal, so it is always more than 120 meter in case of single line. Is it okay? Okay, then we'll move ahead. There is a question, I think, so let me try. Most of you have replied it correctly that it is 180 meter. Though two of you have said that it is 600 meter, two of you have said it is 400 meter, but 180 meter is the correct answer. So let me share the poll result as well as 11 have no answer. So I don't know why they fail to reply to this poll. Okay, then we'll move on. So this is the same thing given in a tabular form, that the block overlap is from the first stop signal, which is the home signal and which is 180 meter, and the signal overlap in case of double line is from the starter signal, and for the single line from the outermost drilling point. So it is 120 meter, and for all other signals is there in the automatic section or with the level crossing gate, it is 120 meter only. We'll move on to the next topic, which is known as falling mark. Now, in the yard, there may be multiple lines. The lines can be as high as, say, 25, 26, 7 meters major station, and can be as low as two line also. So whenever there are multiple lines, they line all these lines converge to a single line or the double line, or at the most to the triple line, because the line number of lines in the block section are only a maximum three. So you can have one line, two line, or the three line. So ultimately, all these yard lines converges to one or two or three lines, depending on the system of working. Now, at the point of convergence, it is quite possible that the train, the two lines which are converging to each other, some movement in one of the line may infringe with the movement in the other line. So beyond certain point, because we have the fixed uh, rolling stock, so beyond some point, there are chances that the train will uh, collide with each other because they are coming too close to each other. When two tracks are running parallel, the distance between the two tracks should be such that two trains on running on this track simultaneously do not infringe with each other. And this distance is 15 feet 6 inches in case of broad gauge. Now, most of the places we have broad gauge, the meter gauge is almost eliminated. But in case of meter gauge, the distance is 13 feet. But nowadays we use the 15 feet 6 inches because most of the sections have the broad. So a permanent mark is fixed in the track at this location where the distance between the two tracks are getting lesser than 15 feet 6 inches to indicate to the driver as well as to the guard of the train that this is the falling mark, and beyond this point there is an infringement to the other line. So it is for the driver to ensure that the train is standing clear of falling mark in the front side, and the guard is to ensure that the train is standing clear of falling mark on the rear side. This is how falling mark are shown on railways, and railways the full word of falling mark is generally not used, and only the FM which is written is treated as falling mark. Now, suppose a train come and is standing like this. On the front side, the train is standing away from the falling mark. The two straight lines shown between the two tracks, the line portion is the falling mark. So the train is standing there on the main line without clearing the falling mark in the front, and if there is any obstruction in case that other train passes because the clearance is not available, there will be some side collision. Now, in this case, the train on the back side or on in the rear is not has not cleared the falling mark, and so similarly, the movement in this way will cause the side collision. And if the train has come in this way, which is clear of the falling mark on the front side as well as on rear side, there is absolutely no problem in running of trains on the other line. So the distance between the two falling mark is typically also known as clear standing room. is the room in which a train can stand and is clear from the adjoining line. So this is also typically known as the clear standing room also. And nowadays the clear standing room is 715 meter. If it is not observed properly, then this type of collision will result. And the question for you is that किसकी गलती है, who is at fault, either the driver or the station master. So you may kindly pick up your chat box and write whether it is the mistake of the uh, driver or the mistake of the station master. Please write in the chat box. Okay, so almost all of you are saying that the driver is at fault. The checking of the fault is the responsibility of the driver. That is clear, is standing clear of the falling mark. And in the front side, it is the responsibility of the driver, and in the rear side, it is the responsibility of the guard. So they should keep their train standing clear of the falling mark so that the other line also do not get obstructed. So we'll move on to the next topic, which is track circuit. And till now, we have covered what adequate distance, and earlier to that was block section. So there will be a short note on adequate distance in your exam. So you'll have to write 5-6 lines about the what do you mean by the overlap or the adequate distance, what type of overlaps are available, and how do they differ, or are they similar, and if possible, draw a line diagram also to explain that. Now we come to the next topic, which is track circuit. This is important because you will have a full question on the track circuit. Full question means whenever I say full question, it is a question which has to be replied in one page, not in 5-6 lines. So you can say around 15-16 lines you'll have to write on this. So you will have a full question on track circuit. Now, track circuit is the arrangement which was invented in 1872 but still in use. It is the simple circuit by which you can verify whether the line is occupied or not. So it is used for finding the occupation by a train and for no other purpose. So occupation of a section of a section in the yard as well as in the block section is verified by the track circuit, and the track circuit displays available with the station master. So the station master, without even going out, can verify in the yard which all lines are occupied and where the train is standing, whether standing or it is moving. So these track circuits are the basic safety device which was used, which is in use since 1872. So this is the diagram, a simple diagram. So let me annotate it also. And this diagram you will have to draw in the, as the question says, explained with diagram. So you'll have to write the show the diagram also. This is the battery. This is the battery, and generally on railways, the 4-volt battery are used, and to make it 4 volt, two batteries of 2 volt are used this side, and the positive is connected to a resistance which is used for reducing the voltage which is going to the track. So 4 volt is being sent. So after some reduction through the resistance, the voltage and the current goes to the track. This is track. So it goes to the track, moves on to the other side of the track circuit and reaches the relay. And the negative side from the relay, again the same thing, reaches to the negative end of the. So this way we are passing certain current and voltage from the battery to the relay. In case wherever there is a disconnection in the rail for any reason, we the bond wires are provided so that there is perfect connectivity across the joint in the rail. So accordingly, there are bonds wire. So bond wire are used to provide the connectivity. So whatever fed from the battery and through the resistance passes to the other side, reaches the relay, and this is the situation we say that the relay is energized. The current and voltages are reaching to the relay, so the relay is energized. These two are the insulated joints so that whatever is fed does not enter into the other section. Similarly, this side also there are joints available so that insulation available so that the current and voltage does not pass on to the section which is not intended as yet. So this way, in case you have a vehicle standing here, say a vehicle standing here, if this is the location of the vehicle, then vehicle is in the form of axle. So the battery voltage or the current passes through the axle, gets short circuited, and returns back to the battery. So nothing will reach to the relay. So the relay in that case will be de-energized. Now this occupation can be anywhere from this place to this place. Can the occupation can be anywhere, or the vehicle may be any location, but wherever the vehicle is, the vehicle or the axle is used to short circuit the battery. So the battery gets short circuited, nothing reaches to the relay, so the relay is de-energized, or we popularly known as drop. So when the relay is de-energized or drop, it means that there is an occupation in this track section, and if the relay is energized or picked up, then the track portion or the track section is free. So this way the track circuit functions. So it is basically the passage of electric current provided by the battery. The current reaches to the other section, then occupation causes a short circuit, and the current is passed through the rail, and the system is known as track circuit. And we have insulated joints on both end of the track circuit so that whatever you feed does not reaches, does not crosses, or does not go into the unintended section. So again, the same thing. And relay used in the drag circuit is used to sense a drop in the current. So if the current drops to a level where the relay drops, then it is considered as the occupation in the track. So we have a question, but we'll come to the question later on. Is there another diagram which shows how the track circuit function? And you can see the diagram that the whatever is fed from the power source, it reaches to the relay. That means there is no occupation. And if it does not reaches to the relay and the relay gets de-energized, then obviously you have the occupation of the track section. This is another way of the same thing. The track, as shown in the red line, is connected to the positive terminal of the battery and is also known as positive rail. And the rail portion which is connected to the negative side of the battery is known as negative rail. So we have the positive rail as well as the negative rail in the track circuit. The negative rail is also used for carrying the traction current, which will get which is earth at multiple locations. Is the way how the insulation joints are there in the track. So let us go back to the question. We have a question on this. Let me see. So this was the tricky question wherein 35 of you have said yes, bond wires will be required even if the rail is welded. Uh, 32 have said no, the bond wire will not be required. And one has no idea. And one has said what is a bond wire. And 17 failed to reply. No, if the rail is welded, then the bond wire is not required because the purpose of the bond wire is to provide the connectivity of current and voltages in the rail if there is a breakage in the rail. If there is some gap in the rail or for any other reason there is some fracture or breakage in the rail, then only the bond wires are provided. Otherwise, there is no point in providing the bond wire. So bond wires are not required, mostly banded. So that was the correct answer. But okay, fine. But one of you has replied that what is a bond wire? So he may please ask what is the reason of asking that what is a bond wire, if possible. And one has had no idea also. I'm not sharing the individual result. But if anybody, okay, then I'll give time for asking question also. So that can be done later on also, and let me see if I have another conversation on this subject. So here is also a question which can be replied as per your common sense. Then this is the result. Most of you have said the track. However, some have replied yes also, and who have said why we have mud in the track. So on Indian Railways, we open section are there. So where whenever there is a rain, some reason like drainage the track, it is quite possible that the rain or the drainage brings mud in the track. So there may be mud also whenever there is leakage in the current. So whatever you are feeding from the battery side, it may be possible that the sufficient voltage or current does not reach us to the relay, and the voltage and current, if it get reduced below a certain point due to mud or leakages in the track, then the relay may get dropped even if there is no occupation on the track side. So mud may cause a failure of the track circuit. Mud may cause the track circuit to drop. Mud may cause the track circuit to show occupation. But the track circuits are not meant for detecting mud in the track. There uh, may be there, excess rain may be there, excess may be there. So it is not used. It is not meant for detecting the mud in the track. So that may come that because of failure of the track circuit, you may see that there is some mud or is there, and I in the diagram I showed earlier there is a resistance also. So the resistance value are changed if the voltage of the current reaching to the relay is getting reduced because of more leakages in the track. So it is always tried that the relay should or the track circuit should for any other reason other than the occupation. So that is because of the track. which is offered by the train or by the axles are 4 to 5 million only. So it is basically a short circuit. There are some of the purposes of providing circuit, let's say, and you take in the first case, this train is standing like this and it is occupying the bursting track. So, if the train is occupying the bursting track, it is there on this line. So, the signal should not be cleared for this line because there is a occupation. So, the home signal will not come for main line. On the other side, if this is the point, this is the track circuit which is covering the uh, when standing like this, it is known that the falling mark is not clear, so no movement should be in this direction as well as the no movement can be permitted in this. So in this case, the home signal itself will not be cleared for any of the line. In the third case, this is the track circuit which is provided for the point zone. So in this case, if this track circuit is uh, under occupation or with some vehicle, this point operation will not be permitted because this will be a case of moving of point under wheel. So that should not happen, otherwise it will cause derailment. Similarly, in the another case, so this is the advanced starter and you have a track circuit like this. So as a train moves from the station and occupies the track circuit, it shows that the train has moved on the signal. So the signal should fly back on or should signal should go back to red. So these are some of the uses for the track circuit as shown in the diagram. And because of the normal track circuit of the DC track circuit, we call it, requires that the insulation to be provided on both ends. So insulation means cutting the rail, providing the insulation, and then welding it again. So the insulation joint provides a this kind of thing in the tracks, and it is not normally preferred because it is a weak link on the track. So other track circuits which are there are audio frequency track circuit. This audio frequency track circuit does not require a rail to be broken, or the rail should have a uh, insulation provided on the track. So these are audio frequency track circuit. They work on the principle of transmitting same frequency. Then we have the Excel counters also. The Excel counter, whenever the Excel moves, the Excels are counted, and if the in count is matching with the out count, then the section is clear. If the in count is more than the out count, that means the vehicle is standing on the track. How a diagram for the Excel counter, there the one of the coil which is on the right side is the transmitter, the coil on the left side is the receiver. So the transmitter, whatever transmits is received if there is no Excel over it. So as and when the Excel passes, there is a disconnection between the transmitter and the receiver, and so it is counted as one, or the Excel gets counted. So this is the way Excel counter works. You can see the other diagram also. There are two track devices on the two side of the track circuit. The one provides the in count or the out count. The other provides, in case the earlier hand one is provided in count, it provides the out count. And if the train in the moving in the other direction, it provides in count also. And both of them matches, then that means that the track section is now clear. This is how the Excel counter coils are installed on the track. I have a question for you, but let me.
Mm.
I don't have a question, so let us move ahead. So we'll come to the last topic of today's, that is regarding point. And after this topic, I will close down this session and we can have discussion and the question answer session will be there. So I told you that there are multiple lines in the yard. So multiple lines in the yard are somehow meeting at one point, and this meeting can take place only at the location which is also known as point. Or, you can say if you are looking at the side, it is there for diamond train which is being received from the block section. Say all trains are received on one line and they have to come on multiple lines on in the yard. Some trains have to come on line number 3, some trains have to come on line number 4, like that. So all that divergence takes place only through the point. So train come and gets diverted to the concerned line, or the train from the lines are getting merged on a single line, double line or the third line. So kindly be with me in this presentation because you have a full question on point in the exam and you are supposed to draw the diagram also. So let me state so that you can understand what is the point. In a point, there are back lines are rails only. So on this tracks, you on this point you have a rail like this. This is also a rail which in the direction as shown and going up finally. Similarly, you have a rail like this and rail like this, and then the rail goes straight like this. These rails are permanent fixtures and they are known as stock rail. These rails are non-moving rails, so they are stock rail and they are fixed at a particular location. They will not move. The only moving region is just a minute. Please hold on. Please hold on. Please. Disturbance somewhere will always happen. To stop it, convert it in a different way. Stock rail, stock rail, and up. So the train can be made to either go straight, either go down. So that is the property of the rails which are designed to move is known as the tongue rail or the switch rail. So this rail and tongue rail, they both be tied together by stretcher bars. So both of them will move together. This tongue rail moves, then this tongue rail will also move for a fixed distance. If this moves by 10 mm, then this will also move by 10 mm. So since both of them are tied together, so we have a stock rail, tongue rail, or switch rail, and similar stock rail and switch rail causes a diversion as the facing direction. Now this is the direction causes diversion. The train may go straight. The train may be diverted on left side. So this is known as the facing direction. You should always see it in the facing. So whatever is on the left is left hand. So the stock rail is left hand stock rail, tongue rail is left hand tongue rail, and whatever is on the right is the right hand stock rail. And similarly, we have the right hand tongue rail also. So friends, we'll have to always stand in the facing direction only to tell what is wrong, what is on the left. So
Sir, actually, your voice is distorting from past 5 minutes.
voice is getting distorted. Uh, just a minute. Is it okay? Is the voice okay now?
Yes, sir.
Okay, I muted and muted myself. That's only I can do because the is a high speed net, so I cause any problem. I don't know. So should I repeat the point?
Yes, sir.
Okay. So
Yes, sir.
okay. So we'll discuss about the point again because it's important that you have a full question on the point and should not miss the point is and the point discussion right now. So this arrangement, as you see on your screen, is known as a point. The point is used to divert a train. Since the train does not have any steering wheel, so all diversion and conversion takes place only on the point. Only the driver can control the speed, nothing more than that. On what line the train is being received and what line the train is dispatched to what line again is decided by the points in the yard, not by the driver as well as not by the station master. So the train follows the path as set through the points, and then the speed while passing over the point is generally kept low so that the train easily traverses the path and then reaches to the destination. So we have this arrangement, which is also known as point, and such points are there in the yard. If more is the complexity of the yard, then definitely more number of points in the yard. And if the yard has less complexity, then the number of points are less. So, depending upon the number of points are there in the yard, it the complexity of the yard. So, let us discuss what a point is. I can annotate myself that I discuss about the point. So the point has some rates which are fixed, which cannot be, and which is known as the stock rate. So this is a stock rate. Similarly, this is also a stock rate. So two main rails in which are stock rail are fixed structure. They are the non-moving structure of the point. And the structure of the point, which is this, which is known as the tongue rail, and is also known as the tongue or the switch rail. This is all is the tongue rail or the switch rail. So these two tongue rails are tied together to the stretcher bar. This is stretcher bar. So they are tied together by the two stretcher bar so that whatever tongue rail on the top moves, the same distance the tongue rail in the bottom also moves. So if the top one moves by say 10 mm, then the bottom one also moves by the 10 because they are tied together. Now that is where where the tongue rail moves up in a way that there is no gap in the tongue rail and the stalk rail. So whatever wheel coming in this direction will move straight. Only the wheel on the bottom side will also move straight because there is a gap. So it will also move straight. So the train will go straight. In case the entire arrangement moves down, if it moves down in a way that this rail is touching this rail, both are touching each other, there is no gap. So then the wheel on this side will move, no gap will move up. Similarly, the wheel on this side, there will be gap here, so will move up. So the train will be diverted and will be diverted to on the left side. So the train will reach, will go to the line there on the left. So in this way, the uh, straight direction as well as the train will move in the on the diverter. And where you can see the arrow is there, it shows the facing direction. Direction which causes any direction which causes the diversion of the train is known as facing the direction of the point. Now this is the facing direction. The train may move straight and train can be diverted. On the other side, train moving in this direction or a train moving in this direction, if both the trains are converging with each other and converging to the line, which is maybe the main line or maybe the any. So whatever causes convergence is the trailing direction of the point. Now consider situation that this is the facing direction, and the facing direction the point is not properly set. So there is a gap here and there is a gap also here. There is no proper setting of the point. Then in that case, whatever on this side goes straight will go on the left on the diverted wheel on this side. Since there is a gap here, will go straight. So the two wheels which are tied together by the will be moving one portion of the wheel will be moving on the diverted, one will go straight, so the train will get the rail. So the setting of a facing point, perfect setting of the facing point is of utmost requirement. And if the point is not set in the facing direction, then it will for sure will cause derailment. Consider the case here if the two are in gaps. So consider the case this tongue rail should butt with this top rail, but there is a gap. The train by its momentum will force the tongue rail to set. Will force the tongue rail to set and the train will go straight without any problem. Similarly, direction requires that this should be set. If it is that's showing in some gap in between, then the train will go straight and by its momentum force the tongue rail to set. So the trailing direction, the point, if, even if it is not set properly, no, any But in the facing the not Then we'll move further on the point and crossing. So this is the way the point looks like on this is something different which is also known as trap point, and this is this it will get derailed here. So the trap points are created so as to cause derailment for any unintended movement, and only intended movement will go through. So these things are this point is known as trap point, and it is also the railway. So various purpose will be known later on. So this way have the facing point as well as the training point. The point which causes convergence is called a trailing point, and the point which trains get down is the point. Use your chat box. With facing or a max. It unique. No, it is a trailing point. Some are writing facing. No, it is a trailing point. So this how the answer should be uh, that these are facing or these are trailing points. So let us move ahead. Improper setting of facing point, as I explained, will cause derailment. An improper setting of trailing point will not cause derailment but may cause damage to the point. So it is this condition of causing damage to non-setting of the point in the trailing direction is also known as trail through or busting of the point technique. So let me stop here and then I'm ready to answer your question. So I will stop sharing uh, the presentation. I'm ready for any question if it is there in your mind. But mind it that question in the exam on the point, there you have to explain what is a point, then what is a trailing point, what is a facing point, and also the diagram of the drawing the point if it can be drawn. Similarly, you have a question on track circuit, and the track circuit diagram has to be drawn, it has to be explained, and both are full questions. So you have to write the answer in single page or one page. Yes, please.
Sir, why single line overlap was larger than double line?
Single line overlap because single line is always considered having safety requirement to a limited extent. Safety is not that much. In the double line, always there is a directional movement. So in the case if you have a directional movement, then safety is much more than the single line. And even if the overshoot, if a train overshoot, then also the chances that since the trains are moving in same direction, chances of collision is not there. But in case of the single line, the train may be coming from the other side also, so some more distance are required as they overlap, so that there is no obstruction or there is no problem or there is no collision with the train, even if the train which is supposed to stop at the starter signal passes over it and crosses it. Suppose a train, if it is coming in the say, if you choose and choose the direction, if the train is coming from the down direction and is supposed to stop at the start, is the train may cross for some distance, but the other train which is coming may be coming to in the up direction and was being received on line number three. So line number one, three, there is absolutely no problem, but this gave rise to the chances of collision. So the overlap distance is always kept more in single line as compared to the. There's a question already there in the chat box which says how was point B the trailing point for train Z? Point B is a trailing point for train Z because it is causing convergence of the trains and the train is coming from the top. So at point B it is converging to the main line. So it is a trailing point.